Hello and welcome to the Slackware ARM YouTube channel. This is Slack Chat Season 2. I'm Stuart Winter. I look after the ARM port of the Slackware Linux distribution. I develop it and act as the architect for it. And we have Phil. Hi, Phil.
Hi, Stuart.
How are you doing?
I'm exceedingly well today. How's yourself?
Pretty good, I suppose, all things considered. And Phil is the maintainer and developer of the SARPI project. SARPI, you can see it as an extension to Slackware ARM. It's an enabler to allow you to easily install Slackware ARM on Raspberry Pis. We're going to be following the development of the ARM port, in particular, following the development of the new ARCH64 port for Slackware, which I'm doing. In this particular episode, we are going to be reinstalling the secondary ARM build machine. And I've now completed what Patrick was calling the big merge. I've done a system integration test on the lead machine, tested KDE, I've tested XFCE. The whole system has been soak tested for about a month now. So there hasn't been any changes pushed out to Slackware ARM for about a month at this point, because that was a huge change. I haven't done that much work on Slackware in a short space of time for quite some time. So there was quite a lot of work to do. In partly, it was because I'm making changes to the build system to support ARCH64 as well. So even before I start building packages for that platform, I'm updating my tool set and making it so that I can more easily do that port. So that's taken a little bit of time as well. In this episode, we're going to reinstall the secondary build machine, and I'm just going to run a final systems integration test on it. I always do that before I push out any big change. And also when there's a new kernel, I tend to reinstall at least one of the machines to make sure the installer all works and everything like that. So it's really important that when the users download all of the software, the updates for Slackware ARM, that everything has been soak tested and everything is linked together. I always reinstall and then run a system integration test on a brand new installation, just to make sure that there's no residue on the primary one that might have polluted things. And it happens from time to time, although it's quite infrequent these days. But here we go. So what we're going to do, the secondary build machine is an Orange Pi Plus2E. That's the name of it, an Orange Pi Plus2E. And it is physically attached to the USB bus of my x86-64 laptop that runs Slackware 64 14.2. This is the way that I document Slackware ARM to be installed. You access the serial console of the ARM device. You configure the bootloader through the bootloader's console. Other distributions tend to do it a little bit differently. A lot of people tend to follow this mini root, images as they call it. There are mini roots for Slackware ARM. Back before there was a generic, well, you needed a kernel for each different ARM device, and that was just a real pain. So I made a mini root file system that I could easily boot up on a new device. It was just a bit of a crutch, really. It's not required whatsoever anymore. I haven't touched a mini root file system for years. They keep being rebuilt, but I don't need them. Some people do like pushing those out, but I don't like that. I think it doesn't make that much sense to me when you've actually got an installer that can install it properly and you can configure what you'd want to install there and then. That makes the most sense to me. Certainly with Slackware ARM, as you'll see here, the fact that the Slackware installer has always been curses based, it's text based, that lends itself beautifully to installing over the serial port. It's great. So I don't know why other distributions don't do this. There are some reasons why you might want to supply a disk image, because it could be easier for the users. But to me, as long as it's documented properly and you can follow it to the letter, then I think that's the best option. So that's the one that I provide. So that's what you're going to see today. Okay, so yeah, you can see that the USB serial adapter is connected to the serial bus of my x86 machine here. Because I'm going to reinstall this machine, I'm not going to shut it down gracefully. It takes too long. There we go. Well, it doesn't take that long. It takes like maybe 10 seconds or something. But I think I said in a previous episode that I will do a tutorial of how to install Slackware ARM 15 when that's released. For the time being, what I'm going to do here to make it a bit easier for myself, and also because I can't follow the public documentation yet because the Slackware ARM updates aren't pushed to the public FTP server at the moment. So I need to do it all off private LAN. So what I'm going to do, and I'm just going to open this up. Now this file is not available on the public FTP site because it's just a bunch of notes. There's something I'm going to show you first, actually, and if anybody knows the solution to this problem, I don't know if this is a bug or not, but watch what happens when I select this. If I select the whole line and then I paste it, be careful not to select the end of the line, but just select everything. Now watch this. Boom. Can you see that it's truncated on the end here? Yeah. And it's not that it's just wrapped. It's not that it's to do with line editing. It's literally truncated. On another version of U-Boot on my trim slice, which is a very old version of U-Boot, this doesn't happen. You can paste in very long lines and it works perfectly. It was only when I started building U-Boot for the Banana Pi that I realized this. And I don't know if it's a configuration option of U-Boot or whether it's a bug. If anybody knows, please tell me, because I'd really like to know. Otherwise, I have to do it like this. So this is what I recommend. So when you're following the installation documentation for Slackware ARM, I think I actually made a note about this in there, but this is what you should do because it works this way. I'll talk you through briefly what I've done here. So on this particular case, this machine was obviously already installed. It was running Slackware. So I've just rebooted it quickly using sysrq to make it faster. You've got U-Boot here. Don't do this on the machine you care about because it's not a graceful shutdown. This is what you use as a kernel developer.
I was gonna ask you about that actually.
That's what that is. It's also quite good if you can't reboot because you've screwed up the operating system. You can address the kernel directly here, the magic sysrq trigger, and it reboots the machine. I've used it many times because most of my ARM machines are not physically where I am, they're elsewhere. If it crashes, I can't really do that much. I mean, there are options. I've looked into more advanced serial options. I even thought about having a remote access KVM, but you know, it's like, okay, I've got to stop somewhere. That's for the most of the part, everything is fine. Okay, so U-Boot has loaded, it scans the USB bus and all that stuff. I've interrupted the boot sequence. This thing here is the U-Boot console prompt. It's nothing to do with Linux. We're not in Linux now, we're running U-Boot. I'm telling U-Boot to get an IP address via DHCP 3 times because I have some weird network issue. Although actually, the network issue doesn't exist in my office. It does exist where the ARM build machines are because I've got 2 different networks, 2 different pieces of equipment. So yeah, let's not go into that one. Anyway, just so you know, you can do things like that and it's perfectly fine. So then what I'm doing, I'm loading a U-Boot configuration script here over TFTP. And that's going to configure a number of settings for U-Boot so that you can boot Slackware. So TFTP is going to load this U-Boot script into this memory location beginning here. And then I'm going to tell U-Boot to go and execute the script from that memory location. And that's what we're going to do. So let's press enter. There we go. It's loaded the flattened device tree. It's loaded the kernel. And now the big one is the installer itself. I think it's about 80 megs unpacked. I think I remember seeing that the other day as it was building. The kernel that we're booting is going to be Linux 5.10.5, I think. There seems to be a new kernel almost every day, which is kind of convenient in a way because it's quite nice to exercise all the new scripts and the changes I've been making for ARch64. So as you can see, for those of you who are familiar with the Slackware installer, it is the same installer. There are a few changes under the hood, but really only minimal ones, just to make the ARM port work. That's pretty much it, really. Okay, so yes, Linux 5.10.5. Okay, let's just check. So I don't need to do anything with the disk partitioning because the machine is already configured. I'm just showing you. So you can see here there's a 500 gig SS. Well, it happens to, I know it's an SSD because I can see it from here. So this machine has a 500 gig SSD attached to it. Got 8 gigs of swap. For Slackware ARM, you don't need that much. The reason why I have it is because this is a build machine. So one of the things you want to do is make sure you have enough swap. This here is eMMC. So the Orange Pi has onboard storage. It has 16 gigabytes of onboard storage there. I'm not using the onboard storage on the Orange Pi at all because it's not big enough for what I want to use it for this particular use case. Because this is a build machine, I need loads of space to unpack archives and, you know, install a full installation of Slackware and all sorts of stuff. So I don't use this at all. Plus the fact that when I got these machines, I tend to leave the factory stuff alone. So this, just in case I haven't got it right and I need to recover and boot back into the machine. That was just the way I operated. It's got Android on it, hasn't it, Phil?
It has by default, yeah, on the eMMC.
Yeah, so that's what that is. If I took out my SD card, which has U-boot on it, from the Orange Pi, it would boot Android. So it's still on there.
Yeah.
So yeah, I've got no use case for this. However, if I, for example, was going to do something, some kind of embedded use case for Slackware ARM, in fact, I would use this. I would install the OS onto the eMMC. I've got some ideas about what I might use some of these machines for in the future. I want to monitor the temperature in my greenhouse because I've been tracking it through the years, actually, manually, and for gardening, really, just to sort of see. And then I was kind of curious to see because the temperatures vary quite significantly through the years. You get a frost much. In fact, we got the frost much later last year in 2020 than it was the previous year. Anyway, so let's get back on track here. Ordinarily, what you do in Slackware ARM is you'd run setup like this. And what I'm going to do is run this little script called QGo, which is only in the ARMS installer. And it's just really my convenience, to be honest with you. It just does a couple of things. It sets the title bar. You'll see it says this host name at the top, mojo.arm. Because I have so many screens on the machine I develop on, which is not the one you see, it really helps to have the windows labeled. So let's just run that, call it Mojo. And then it's going to reset the time via MTP because I don't think the Orange Pi has an RTC by default. In fact, it doesn't, does it? It doesn't have an RTC. You have to plug one into the GPIO, I think, don't you?
Yeah, it has. Interestingly, I think it has the socket for a backup battery for the RTC, but doesn't have an RTC itself.
Oh, right. Okay. I have one that I've plugged into it, but I don't think it's in Zippy, which is the lead build machine. I don't think this has one in it. Yeah, but it doesn't matter anyway for this particular use case. I don't need to do the key map. Let's jump straight into adding swap. That will take a moment to do that. Brilliant. Okay, format that as ext4. That will take a moment as well. While we do this, I'm just going to do a stopwatch. I think it takes about an hour and a half to do a full installation on this machine. It might be slightly longer than that, but we'll find out because I'm going to start that timer as soon as it does that. Right, so this should be finished in a moment. There we go. As I said before, I'm not interested in mounting these. I mean, I could mount them inside the OS, but I just don't need to. Let's select NFS, type in my server. Oops, my hands are cold today. I'm making like typos everywhere. Right, that looks good to me. Yeah, when my fingers like cold, it's really difficult to type. I know exactly what I need to do, but it's really difficult. Okay, so that looks all good to me. And I'm going to do a full installation. I always do a full installation of Slackware ARM because Slackware is built on a full installation. And in this particular case, I need to do a system integration test, so I definitely need a full installation. Okay, so that's going to start doing its installation, and that's running it through now. Oops, I forgot to start the timer. There we go. Missed a couple of seconds. Yeah, so that's going to take a little while to install. Okay, so the installer has now completed. It has taken 1 hour, 6 minutes, actually just slightly under that, to do a full installation of Slackware ARM onto an Orange Pi Plus2E. So that's pretty good going, actually. And if we just have a quick look, how much disk space is there? Not that this is really representative of how much time it takes or anything like that, because it's also downloading this off of the network. It's having to unpack it and everything. So we've installed 12.5 gigs of content onto the local SSD there. That's pretty good for a full installation. What we're going to do now, for those of you who are familiar with the Slackware installer, again, it's exactly the same. So I'm going to enable GPM because this particular machine that I use is a desktop testing machine. So I do have a monitor connected to its HDMI output, and that's what I've used to test the desktop environments. So yes, I do. This machine is called Mojo, and it's on the arm.slackware.com domain. I'm going to use Network Manager. Yeah, that's okay. I'm going to enable RPC because I use NFS. I don't need any custom screen fonts. I'm going to select London because that's the closest place to my time zone. Pick VI there. And KDE, I'll leave KDE on as the default. Set a password. And then we do exit. Yes, we do. And the system will be rebooting. So it's just finishing off of Linux. And Linux is done. And now we're into U-boot. This time I'm not going to interrupt the U-boot boot because The only time when you need to interrupt it is if you're going to get into the console and you want to do something other than let the system follow its configured process. The U-boot is already configured to boot the operating system. If you're following the Slackware ARM installation documentation, if I remember rightly, there is a little bit of follow-up work perhaps to do in U-boot. I can't quite remember without looking at it, but once you've done all of that and you've saved it, you don't have to touch U-boot again. So the machine is booting up, it's booting into Linux. This is the first time that it's going to boot because we've literally just reinstalled it. So it's going to take a little bit longer than it would normally. We'll see the machine rebooting in a moment or two because that's part of the reinstallation process for the Slackware ARM build machines. They get rebooted. So yes, it's going to take a little bit longer on first boot because it's setting up the machine for the first time. It's creating the SSH keys, SSH daemon keys. So let's log in. So this is a local login to the machine. This is over the serial console. Remember that underneath here is my machine called Kit, which is my x86 machine. So I'm accessing the Orange Pi serial console from an x86. So I'm logging in over the serial console here. As you can see, we're on TTYS0 rather than say PTS/0. What we're going to do now is just check that I've got an IP address on here, which I do. So that's good. We're going to mount a HD. I'm going to mount my x86 Slackware server onto the ARM box here over NFS. I just pick /mnt/hd because it's one of the directories that is pre-made for you on the Slackware file system. I just go the easy route really. So HD. We also tend to mount things as /mnt/floppy as well, and I haven't physically touched a floppy disk in probably 15 years. I just need a temporary mount point while I do this. So devel. So I'm now going to run the script that I use that configures the Slackware ARM build machines. This isn't anything to do with the installation of Slackware. When you follow the installation documents, you end where it says, log in. That's it. Your operating system's installed. But I'm going to run this setup script here now to configure this machine to make it into one of the build machines. As you can see, I've got this little script. So now I get to choose which distribution I'm building of Slackware ARM. As you can see, I've got three options: the 64-bit port, current, and ARM 14.2. This is ARM current. So it's just going to go and do some local setup stuff, basically, which takes a moment or two. There's a few little warnings and errors in there because it's killing off a few things and changing some config over. It's installing SlackKit, which is it's the build library that I built for Slackware ARM, so I could abstract things like changing permissions, setting ownerships and stuff into a single library. So this is going to take just another moment longer while it does that, and then it will reboot. And the boot will be slightly faster than last time because it will be the second boot. So we don't need to recreate those SSH keys that are already created. So it also installs X11VNC from the /extra directory. The reason for that is because on some of the other ARM build machines, I don't have a physical monitor connected to it. So the only machine I actually have a physical monitor and keyboard connected to is the Orange Pi, this particular Orange Pi that I'm reinstalling. So in fact, you can hear this beep or not, but I've just switched my KVM over and now I'm watching the machine boot on the HDMI monitor in addition to watching it on the screen, because the U-boot console the output of it is also surfaced onto the HDMI monitor. Okay, so the kernel is now starting. So Linux is booting. And there we go. So it's loaded the initial RAM disk modules. Some of you will see these types of error messages from time to time. When you boot, you will see these types of error messages with certain devices. That's simply because the way that I have built Slackware ARM is that it has a generic initial RAM disk which caters for all of the hardware that I support, which means that inside of it, it tries to load modules for those types of devices, even if they're not present on the machine. So when you try to load some of the modules, it says, oh, there's no hardware here, so that's an error. That's okay. It's not something that's going to break anything. For example, on the Banana Pi, I think it's the Banana Pi, or maybe it might be one of the Shiva plugs, actually, that one, because that has an RTC on it. Anyway, so let's log in as root. So you can see my machine's booted up. Also, what the native setup script that you saw me just run before it rebooted, that also configures the newly installed machine to run a system integration test, which is exactly why I've reinstalled the machine in the first place today, because we're almost ready to push the updates out to the public FTP after a month. So what this script does is it performs a system integration test. It scans the file system for the binaries and libraries on there. It checks to see if there are any broken library dependencies there, and then surfaces those, in this case, to a log file. This is really good because this was on, I think, the AArch64 ports to-do list, because I wrote a script called Find What Needs Recompiling many years ago, because I'd noticed that I'd pushed out some updates that had broken library dependencies on there, and some of the packages needed rebuilding. And so I wrote this script to go and find them all, and I shared that with the team, and that was in use for a while. And then Alpha Geek Eric saw it, and he rewrote it in TCL, and it was a lot faster. And I said, oh, that's really good. So I took his version of the script, ran it, it worked. I was like, God, this runs in minutes, and mine takes about 5 hours because mine was written in shell, and it's pretty slow, but it worked. So I looked at the script, and it's like hundreds of lines long, and I was like, he said, oh yeah, I've read the documentation for the ELF format, so he could understand exactly what it was doing. So instead of using tools like LD or object dump, so this script is really, really fast. And Hans in the team has updated it recently because it had a couple of issues with some package file names and stuff. So this script has now recently been updated, and I've switched over my old version of it with this one. So I'm really happy about that, because this takes minutes to run now, whereas previously it took hours. And like we were talking about before, the sooner things fail, the faster I can go and fix it. I'm hoping in this case that everything works, because I have already run it on the lead build machine, so I'm expecting everything to come back clean here. But I'm not going to go and let that finish. We are done on this one, and I'll have a look at that later. Oh no, actually, that's not true. Let me show you something else. I just need to check something else, which I haven't checked actually. Okay. So what we're going to do, as I said in one of the previous episodes, Slackware by default, as it should, does not allow you to log in as root. It ships the SSHD config to deny root login, and that is the best thing to do. But what I've done, because all of these machines are on a private secure LAN, the native setup script changes that file to allow me to log in as root, because it's just easier for me. By default, you can't log in as root to Slackware, not remotely anyway. You can log in at the console, but not for remotely. In this case, I'm logging in using SSH. One of the things that I want to do here is just quickly look at the install report. This is only for ARM though. It does not exist on x86. This is one of the little changes I made to the installer. And it just outputs the install report for each package into the /tmp directory. So when you install Slackware ARM, you'll find this file in /tmp. It's supposed to be there, but you can delete it. It's really for me rather than anyone else. So what I'm going to do just quickly is scan through this. In fact, actually, just perfect. I was just looking to see if there was any output from install package, because what happened in the past was when the packages were installing, sometimes there would be errors thrown up in the do.sh scripts, just ARM related stuff that I had to go and patch. There's no errors from there. So that's good. I should really automate that actually. Actually, that's a good point. I'll add that to the do list, because there's no point in doing that manually, is there? And that's it. So yeah, unless you've got any questions or anything like that, Phil, we'll call this a day.
Okay, no questions. That's all very fascinating. It's really, really good stuff.
Cool. Well, I hope you enjoyed it.
Very much so.
And remember, everybody, to like and subscribe. And if you've got any ideas or suggestions, let us know in the comments. And also, if you're particularly interested in the ARM ports and you want to use Slackware ARM and you find yourself enjoying using it on your hardware and you like this channel and all that stuff, I will certainly appreciate donations. A lot of work, as you can see now, really does go into this. And you can go to the webpage here. This is the Slackware ARM website, and you can donate via PayPal one-offs, or you can use Patreon as well and do it that way around. Where does the money go? Well, the money goes to doing things like buying Rock Pro 64s, which have actually arrived the other day. I have opened the box. I paid for those two, and then the Pine 64 guys gave me the other one for free to help support the project there. But it goes towards things like that, and paying £11.50 worth of customs import duty on them as well, which is quite funny because it's kind of like really a significant amount of the cost of the actual hardware is the customs duty. So if you want to donate, and you are certainly welcome to do that, and it is appreciated. So yeah, like and subscribe. And that's goodbye from me.
And very goodbye from me.